Alright, we're going to look at a second way of solving systems of linear equations in two variables that's called solving by substitution. And the important thing to realize is it's right there in the name and in the instructions. Solving by substitution is when we take something that we know to be equal and we replace it in something else. Like when I get a substitute at school, somebody who is an equivalent kind of teacher comes and takes my place. Okay, so that's what's going on with substitution. So we're going to do some examples of this. Example 1. Now, if you look at these problems, your first thing is you want to say, okay, do I have an equation where I'm solved to one of the variables? And what I mean by that is, like on this one, this is y is solved in this equation because y is by itself. And what y equals is -3. So what we can do is we can substitute in that -3 where our y is, so that we get 3x plus 3 times -3 equals -15. And then from there we have to just solve for x. So 3 times -3 is -9. And then we would add 9 and divide by 3 to finish this off. And when we're done with that, we get the x equals -2. So we got x, and now just like yesterday when we were graphing, our answers are a point, x comma y. And so we just found that x is -2, and we actually know from our problem that y is -3, so our answer is -2, -3. Alright, let's try another one. So in this case, again, we'd say, okay, am I solved for a variable? Yes, I am. I'm solved for y on the first equation. So we're going to take what y equals, and we're going to put it right here where y is in our second equation. So that'll give us -x plus 6 times 2x plus 13 equals 23. So we're going to have to distribute so -x plus 8x, not 8x, that'd be a 12x. And then 6 times 13 is 78, equals 23. And then we've got like terms here on the left side. -x plus 12x is 11x. And subtract 78 from both sides. So that 11x equals -55. Then all we have to do is divide by 11. We get x equals -5. But that's only the first part. We know what x is, so you're going to take this, we're going to plug it in right here. You could plug it into either equation and you'll be fine, but that right there where I've drawn an arrow to, it's going to be easier to use this first equation because it's already solved for y. If we use the other one, we'd have to solve for y in that one, so it would be more work. So 2 times -5 is -10. And we're adding 13 to that, so we get 3. So our point x comma y is -5 comma 3. Let's do another one. So here, if we ask ourselves, hey, is it solved? Are either of the equations solved for a variable? Both of these actually are solved for y. And so it doesn't matter which order we do this in, but I'm going to take what one of them equals and plug it in for the other y. So we could take 4x plus 6 and plug it into the second y. Or if you wanted to, you could do it the opposite way. We could take this and plug it into that y. Either way, we're going to end up with basically the same thing. So if I do it the blue way, okay, if I take 4x plus 6 and I put it where the y on the left side is, I get 4x plus 6 equals -3x minus 8. I need to get my x's on one side and get my numbers on the other. So divide by 7 on both sides, and x equals -2. So in this case, it doesn't matter which one I plug this x back into. So first or second one, doesn't matter. So y equals 4 times -2 plus 6. So that's -8 plus 6, which is -2. So our point is -2, -2. Example 4. Now this is the first case where we have that we're not already solved for a variable, so this is going to require just a little bit more work. The way you should determine what variable to solve for is, if I look right here at this x, there's nothing in front of my x, and so that's the thing that I should try to solve for by adding the 2y over to the other side. The reason I'm picking that is because there's not a number in front of x. Because if I pick any of these other things that I have and I try to solve for those variables, like let's say I wanted to solve for this y, well, I'd have to subtract the 8x over and then divide by 8, which in that case isn't that big a deal. But a lot of times if you try to do that, you'll end up with fractions, and why mess with that if you don't have to? So I got that x equals 2y plus 20 by adding the 2y over. We need to put this where x is in this equation. Okay, because it's x equals, we're putting it in for the x. So watch out for that. Okay, so we need to distribute. We need to add like terms. Subtract the 160 over. So 24y equals -168. We are going to divide by 24 on both sides, and we get y equals -7. And so we take that and we plug it back in to the equation where we are solved for x. So x equals 2 times -7 plus 20. So that's -14 plus 20, which is 6. So that's the point, because this was x the whole time that we were solving. X is 6 and y is -7. That would be our answer. We've done a lot of solving so far. We've got 2 more, but that's okay because these are going to go really quickly because we have not yet encountered a special case. What's going to happen is we've been getting answers that are points, but yesterday when we began talking about systems of equations, we talked about how sometimes you don't get an answer. Sometimes there's no answer at all, and that would be called no solution. Other times there's actually a lot of answers, infinitely many solutions. And so we talked about what that looks like with graphing, and now we're going to talk about what that looks like with substitution. So if I plug in, I'm solved for y on the second equation. If I plug in and I start solving, I'm going to run into a problem. But it's kind of a good problem because it lets me stop the problem early. Okay, right here, 6x minus 6x is 0. So these cancel each other out. What I'm left with is 10 equals 6. Okay, so I can't find an answer for x because I just canceled out x's. Well, what it means is that either it's no solution or infinitely many solutions. And if you can remember this, is this a true statement? Does 10 equal 6? No, it does not. Those are not the same number, and so that means it's no solution. So when you cancel out and the numbers are not equal to each other, it's no solution. There's nothing that would work to get us that. So let's try one that I bet you can't guess what this one's going to be. Maybe you can, I don't know. Remember there's a 1 in front of this y. It's going to help us distribute here if we put a -1 instead of just a negative. So 3x minus 3x plus 16 equals 16. Well, so hopefully we just noticed our problem there again, but this time we get 16 equals 16. that is a true statement, and so if it's a true statement, then that's infinitely many solutions. There you have it.